Hello, this is Jason from Northeastern Junior College. In this video I'm going to show you how to read the color bands on your resistors so you can tell how big they are. And at the very end I've got a different circuit with a force sensing resistor that you guys would probably find pretty cool. Alright, so I need to show you guys how to read the size of your resistors. So those guys are resistors, tiny. But if you look on them, they have little color bands. So each one is colored differently. So if I look at this resistor and I look at it, it looks like brown, green, black, gold. So I'd have brown, green, black, and gold. So these colors mean certain things based off where they're at. And I'll show you guys the chart here in a minute. This gold one, normally you're going to see a gold or a silver one. That means you need to lay the resistor to the right, that color, that gold or silver, to the right hand side to read it. Brown, green, black, gold. I wouldn't start with gold on the left hand side. Okay, so what this means is that brown, if I look at the resistor color chart, and you guys can go online and search for resistor color chart and you'll find thousands of them. But the color brown on the resistor color chart corresponds to, the color brown corresponds to 1. So if I'm reading a resistor, I would write it out, brown, green, black, gold, and I would find on my color chart, and I just write 1. Brown corresponds to 1. Green corresponds to 5, and this is universal, and black corresponds to 0. And gold, if you look at it, corresponds to 5%. Okay, this gold, or could be silver, on this side is the tolerance. For what we're dealing with, we don't really care. We just know that we place gold and silver on the right-hand side. But it's how close is this thing going to be there. Now, this is not 150 ohm resistor. Okay, what it means is, if I've got two colors, and my third color is actually a power of 10. So when I'd write it, I would say, I just literally write the numbers down. 1, 5 times 10 to whatever number I have here. In this case, it's 0. And then I'd have plus or minus my tolerance, 5%. So actually really easy. So in our case, if you guys remember 10 to the 0, or get a calculator and put 10 raised to the 0 power, okay, that is actually 1. So I'd have 1, 5 times 1 plus or minus 5%. Okay, and we know that 15 times 1 is just 15. So I'd have 15 plus or minus 5%. So since, like I said, we don't really care about the tolerance, so this in effect is a 15 ohm resistor. Okay, if it's colored brown, green, black, gold. All right, let's try another one. So I have a yellow, purple, brown. All right, so I'm just gonna flip this over. Yellow, purple, brown. So I'm gonna go yellow, purple, brown, and like I said, in this case it is a gold, but it's a tolerance. I just know that it needs to go to the right hand side, so gold. So I just know that yellow, purple, brown. So then I look at my resistor color chart, and yellow corresponds to 4. Purple corresponds to 7. And I know that my third one is a power of 10. So 4, 7 times 10 to whatever brown corresponds to. Brown corresponds to 1. And then my gold we know is plus or minus 5% based off the chart, but we don't really care about the 5%. So I have 4, 7 times 10 to the 1. So you guys all know that 10 raised to the 1 power is just 10. So I have 47 times 10, which is 470 ohms of resistance. Okay, let's try one more. Let's just make one up. So let's go blue, orange, and orange. And let's say gold. Gold's probably what you're going to find more often than not. So I have blue, orange, orange, gold. So let's say I found a resistor in my kit, and that's what color's on it. And so I'm going to go to my resistor chart, and I'm going to write down the numbers 6, 3. In this case, we know 3 is orange is 3. So I'd know 6, 3. So I just literally write these two numbers down: 63 times 10 to whatever the third one is. In this case, it's orange. So 10 cubed, cubed. And then I'd have my gold here, plus or minus 5%. But I don't really care. So 63 times 10 to the third. Now you guys all know 10 to the third is 1,000. So I'd have 63 times 1,000 plus or minus 5%. So that would be 63,000 ohms of resistance. If you guys have done any metric conversions, you would know the same thing applies with meters and kilometers and millimeters as they do to ohms. So if this is our base unit, it'd be similar to if I said 63,000 meters. Okay, same thing, 63,000 ohms, 63,000 meters. I can use the metric conversion to change it over. So in this case, if I had 63,000 meters, that's equal to 63 kilometers. If I had 63,000 ohms, that's 63 kilo ohms. Okay, so these would be equivalent. So using metric conversions, electricity, you pretty much only use metric. There really isn't very many standard options. So you just use your conversions on that. So you have 63,000 ohm resistor or 63 kilo ohm resistor. So reading color charts are very easy. Reading resistors are very easy, just have to have the color chart. Now if you need to go the other direction, that's pretty easy as well. So let's say we need so we're going to go back the other direction. So let's just choose a resistor that we want. So let's say we want a 100 ohm resistor. That's what the size that we need. That's what we want to use. So I've just got three numbers. We know that the first two numbers here correspond to the first two colors. So 1 corresponds to brown. Okay, 0 corresponds to black. And then our third one corresponds to how many extra zeros we have. Okay, in our case, we've got 1 extra 0. So that would be, we would put brown. Okay, and then our tolerance we don't really care about. So if I need a brown, black, brown resistor, and probably gold, usually. Okay, brown, black, brown, gold. So if I work backwards just to double check our work, we know brown is 1, black is 0, brown is 1, so that's 1 0 times 10 to whatever color this is, 1, right? So then I get 10 times 10, which is equal to 100 ohms. So we know we're looking for a brown, black, brown resistor. All right, I'm going to show you one of the cool little thing that I included in your guys' kits. Okay, you guys will see it if you look at the package. It's called a force sensing resistor. Okay, so what I'm going to do is I'm going to put it in series with I've got my battery, got my LED, put it in series between my LED, and I'm going to add a resistor just to protect my LED a little bit. I'll give you a better view of this here in a sec. So if you look at it, I've got my electricity can potentially flow down my red lead through my LED. Since I'm using a breadboard, it's coming all the way to the end. It's going to go in the resistor, flow through. Okay, it's going to come back out. It's going to flow through that resistor, and now it just needs a path back to the battery. So plug it in, nothing's happening. Right? So the cool thing about this thing, it's a force sensing resistor. So if I put my hand on this, my finger on it, and I create some force, I can adjust how much current flow is flowing through it by how hard I press. So the harder I press, the lighter it gets lighter. So you could make all kinds of cool things with this. When you guys get into some more advanced circuits, once you played with this and kind of got bored with the LED, Go to All About Circuits or go read some other books. There's a lot of really cool circuits you can create. Security alarm. You can do almost anything you want to. But this is a really cool thing. You have to touch something in the right spot to turn on the electricity. One other thing, I'm not going to show you guys how to use this because it's going to take too long. But if you've got one more package. These are called capacitors. Okay, so what they are a way to store just a little bit of electricity. Okay, so the schematic symbol for the capacitor for this black thing, this is actually called electrolytic capacitor. Basically what it is it's two plates like that. Okay, so I've got two wires, wire coming into both sides, and there's just two plates, and there's actually a gap between one side of the wire to this side of the wire. So DC voltage won't flow through. So if I put a capacitor in my circuit, so let's say I just put it in series up here, right? If we look at our circuit, my loop can't be complete, right? Current will not flow through this gap. It's a disconnect. But that's not what these are used for. These are used to store things. So when you get into some more advanced circuits, what it'll do is it'll store up electricity. So if I hook this to 9 volts, I hook this to my battery, let's say. Battery. Like that. Okay, my loop's not complete. There's no way for current to flow. But what will happen is I will get 9 volts stored on this capacitor. So when I disconnect the circuit, disconnect my battery, my capacitor actually still store 9 volts on it, but it's a very small amount of energy. It's not very useful. I can't power a light or anything else with it for very long, but I can use in some circuits as timers. So if I need to create something that turns on and off, I use capacitors to add time into my circuit. But you guys are going to have to go do some research and do some reading to figure some of this out and draw some of these. But that's what capacitors are normally for in a DC circuit. So guys, go play with this stuff. I think this is the end of the basic electricity, kind of going through all the parts in the kits. Take a look at things. If you guys have any questions, please give me a call. You guys all have my contact information. You guys know where we are at Northeastern Junior College. So don't hesitate to ask us or bring in a really cool project that you're working on, and we'd be more than gladly to post it to our Facebook page, things like that. So well, thank you everyone. Talk to you later. Bye.